we see something that we think law enforcement's doing improper work that's going to not be caught until it gets to court, we've got to teach it. We've got to teach it the right way, and that's part of the process with Trimble forensics.
I'm Calvin Rikard with Duncan-Parnell.
And I'm Thomas Erdmann from Seiler Instruments. Both Calvin and I work for authorized Trimble dealers. And our purpose in this week over at the Trimble facility in Dayton, Ohio, is to look at some UAV drone or mapping of crash or crime scenes. And what we're really kind of diving into is mapping in several different kind of ways of doing it and looking at the accuracy. We're a little concerned about some of the ways that police agencies may be using their photogrammetry UAV mapping to then make scale diagrams or measure skid marks, final arrests of evidence, and making calculations off of those. One of the things that we're looking at is if you scale something in your intersection and then you get further away from that area where you scaled, where is the error rate, or what is the error as you get further away? Because we know that what you need to look at is in your intersection where your crash is, or on the roadway where your crash is. One of the things that we always talk about is your approach to the crash is part of that crash, and they may be further away around a corner on the other side of the hill. And if you're taking measurements over there as opposed to where you scaled it, where the actual crash occurred, what is the accuracy? One of the other things that we're going to be looking at is the elevation accuracy. We're finding that if it's a very flat roadway, it looks like you're pretty accurate when you lay it over maybe a GIS map. But when you start introducing elevation, we're kind of researching what is our error in that. And Kevin wants to show you some things that some examples of why we've been kind of alerted to this and why we're doing some testing.
Shots where a car comes to final rest and some other objects there at the scene. And we're good with that until we turn on the actual photograph that the UAV produced. And when we look at the ground control points, we can see that there's a 100-foot scale here. And when we zoom in onto the measurement, that looks good. But the further we start to get away from that scale, this is where we started to really see some concern, was the final rest of the car in relationship to the picture in the actual total station data was considerably off. And so we had some other data that was given to us, and when we look here at these two data sets, we can see that we have GNSS data overlaid on top of Google Maps. And what I'd like to bring your attention to is especially the end of this guardrail is matching up pretty good with the Google Maps. But then when we look at the UAV data, and when the scale is down here closer to the intersection, it's a little off, not much, but as soon as we get further away, we look here at the guardrail and we can see that there is considerable distance between the shot from the GNSS and what the picture that was produced by the UAV is showing. So some premature data that we've gotten so far. with the data that or testing that we're done here in Ohio is here is the area that we flew the drone. We have 3 control points that you can see here, but it still kind of looks like a bowl shape data set that we have. But then when we use 5 control points spread out throughout our collision, this scene, then we can start to see that there is a lot of elevation that actually this first photograph is missing. We start to see that elevation, I think, in true form of what is actually out there that we actually flew the drone. So
what what we're really testing this week is flying a mission and then taking those photos and processing it in many different ways. And the first way is to really look at it in the way we feel is the proper way to do it, is to map these ground control points spread out through the scene with a GNSS or a total station, and then take those ground control points into your photogrammetry software and process it. And then compare it to just scaling it with one area in there in your scene with maybe a steel tape of a known measurement, and scaling it and seeing where at one end of the scene do things line up where they should, and what are the elevation changes, are the elevations accurate in that way of doing it. And then another way of just taking, scaling it maybe 3 times throughout the scene, so you're not just at one end or in the middle, but you're actually throughout the scene and scaling it with a steel tape, and then processing it that way.
And what I'd like to also add is, we're running the scanner out there, and with the latest update and giving us the option of actually doing a precision point, a very specific point that is being scanned and placed into the point cloud itself, taking that data, putting it also into the processing of the UAV data, and then seeing how all this intertwines together using total station, using GNSS, using scan data, using scale data of known measurements out at the scene. So pretty exciting to find out what these results are going to be once we get this data, all of the data processed.
Right.
So.
And we'll be able to lay all that data on top of each other on different layers and turn it on and off and show which data we've come out to the really the most accurate way of and what we feel is going to be the best solution for gathering the ground control points and processing the ground control points.
And then being able to educate, the people that come in contact with these proper procedures, so that they're not having to answer very tough questions at a later date and time, in the court setting possibly. So
correct. Yeah, so stay tuned for our results. We're pretty excited what we're going to come up and we'll be able to show you.
Thank you.
Thanks.
See something that we think law enforcement's doing improper work that's going to not be caught until it gets to court, we've got to teach it. We've got to teach it the right way, and that's part of the process for Trimble forensics.